Earth is the third planet from the Sun, the densest planet in the Solar System, the largest of the Solar System's 4 terrestrial planets, and the only astronomical object known to harbor life. According to radiometric dating and other sources of evidence, Earth formed about 4.54 billion years ago. Earth gravitationally interacts with other objects in space, especially the Sun and the Moon. During one orbit around the Sun, Earth rotates about its own axis 366.26 times, creating 365.26 solar days a one sidereal year. Earth's axis of rotation is tilted 23.4 degrees away from the perpendicular of its orbital plane, producing seasonal variations on the planet's surface within a period of one tropical year. The Moon, Earth's only permanent natural satellite, by its gravitational relationship with Earth, causes ocean tides, stabilizes the orientation of Earth's rotational axis, and gradually slows Earth's rotational rate. Earth's lithosphere is divided into several rigid tectonic plates that migrate across the surface over periods of many millions of years. 71% of Earth's surface is covered with water. The remaining 29% is landmass, consisting of continents and islands, that together has many lakes, rivers, and other sources of water that contribute to the hydrosphere. The majority of Earth's polar regions are covered in ice, including the Antarctic ice sheet and the sea ice of the Arctic ice pack. Earth's interior remains active with a solid iron inner core, a liquid outer core that generates the Earth's magnetic field, and a convecting mantle that drives plate tectonics. Within its first billion years, life appeared in Earth's oceans, and began to affect the atmosphere and surface, leading to the proliferation of aerobic and anaerobic organisms. Since then, the combination of Earth's distance from the Sun, physical properties, and geological history have allowed life to evolve and today thrive. The earliest undisputed life on Earth arose at least 3.5 billion years ago. Earlier physical evidence of life includes biogenic graphite in 3.7 billion-year-old metasedimentary rocks discovered in southwestern Greenland, as well as remains of biotic life found in 4.1 billion-year-old rocks in Western Australia. Except when interrupted by mass extinction events, Earth's biodiversity has continually expanded. Although scholars estimate that over 99% of all species of life that ever lived on Earth are today extinct, there are an estimated 10 to 14 million species still in existence, of which about 1.2 million have been documented and over 86% have not yet been described. More recently, in May 2016, scientists reported that 1 trillion species are estimated to be on Earth currently, with only 1,000% described. In July 2016, scientists reported identifying a set of 355 genes from the last universal common ancestor of all organisms living on Earth. Over 7.3 billion humans live on Earth and depend on its biosphere and minerals for their survival. Earth's human population is divided among about 200 sovereign states that interact through diplomacy, conflict, travel, trade, and communication media. Name and etymology. The modern English word Earth developed from a wide variety of Middle English forms, which derived from an Old English noun most often spelled eord. It has cognates in every Germanic language, and the Proto-Germanic root has been reconstructed as *er, though in its earliest appearances eord was already being used to translate the many senses of Latin terra and Greek gamma, the ground, its soil, dry land, the human world, the surface of the world, and the globe itself. As with Terra and Gaia, Earth was a personified goddess in Germanic paganism. The Angles were listed by Tacitus as among the devotees of Nearthus, and later Norse mythology included Jorth, a giantess often given as the mother of Thor. Originally, Earth was written in lowercase, and from early Middle English, its definite sense as the globe was expressed as the earth. By early modern English, many nouns were capitalized, and the earth became the earth, particularly when referenced along with other heavenly bodies. More recently, the name is sometimes simply given as Earth, by analogy with the names of the other planets. House styles now vary. Oxford spelling recognizes the lowercase form as the most common, with the capitalized form an acceptable variant. Another convention capitalizes Earth when appearing as a name but writes it in lowercase when preceded by the E. It almost always appears in lowercase in colloquial expressions such as, "What on earth are you doing?" Chronology. Formation. The earliest material found in the Solar System is dated to 7,456,720,000,000 spade suit 4.5672 plus or minus 0.0006 billion years ago. By 7,454,000,000,000 spade suit 4.54 plus or minus 0.04 GYA, the primordial Earth had formed. The formation and evolution of the Solar System bodies occurred along with those of the Sun. In theory, of solar nebula partitions of volume out of a molecular cloud by gravitational collapse, which begins to spin and flatten into a circumstellar disk, and then the planets grow out of that disk along with the Sun. A nebula contains gas, ice grains, and dust. In nebular theory, planetesimals form by accretion. The assembly of the primordial Earth proceeded for 107014631152000 spade suit 20 Ma. The process that led to the formation of the Moon approximately 4.53 billion years ago is the subject of ongoing research. The working hypothesis is that it formed by accretion from material loosed from Earth after a Mars-sized object, named Theia, impacted Earth. In this scenario, the mass of Theia was approximately 10% of that of Earth. It impacted Earth with a glancing blow, and some of its mass merged with Earth. Between approximately 4.1 and 7 quintillion 380 trillion spade suit 3.8 GYA, numerous asteroid impacts during the late heavy bombardment caused significant changes to the greater surface environment of the Moon, and by inference, to that of Earth. Geological history. Earth's atmosphere and oceans formed by volcanic activity and outgassing that included water vapor. The origin of the world's oceans was condensation augmented by water and ice delivered by asteroids, protoplanets, and comets. In this model, atmospheric greenhouse gases kept the oceans from freezing when the newly forming Sun had only 70% of its current luminosity. By 7 quintillion 350 trillion spade suit 3.5 GYA, Earth's magnetic field was established, which helped prevent the atmosphere from being stripped away by the solar wind. A crust formed when the molten outer layer of Earth cooled to form a solid as the accumulated water vapor began to act in the atmosphere. The two models that explain land mass propose either a steady growth to the present-day forms or, more likely, a rapid growth early in Earth history followed by a long-term steady continental area. Continents formed by plate tectonics, a process ultimately driven by the continuous loss of heat from Earth's interior. On timescales lasting hundreds of millions of years, the supercontinents have formed and broken up 3 times. Roughly 7 quintillion 16 quadrillion 236 trillion 682 billion spade suit 750 Ma. One of the earliest known supercontinents supercontinents Rodinia began to break apart. The continents later recombined to form Pannotia 600 7016 1704 1104 Spadesuit 540 Maya, then finally Pangaea, which also broke apart 7 quintillion 15 quadrillion 568 trillion 36 billion 800 million Spadesuit 180 Maya. The present pattern of ice ages began about 7 quintillion 15 quadrillion 126 trillion 230 billion 400 million Spadesuit 40 Maya and then intensified during the Pleistocene about 7 quintillion 13 quadrillion 946 trillion 728 billion Spadesuit 3 Maya. High-latitude regions have since undergone repeated cycles of glaciation and thaw, repeating every 40701231556 Spadesuit 100,000 years. The last continental glaciation ended 10,000 years ago. Evolution of life. Highly energetic chemical reactions are thought to have produced self-replicating molecules around 4 billion years ago. This was followed a half billion years later by the last common ancestor of all life. The development of photosynthesis allowed the sun's energy to be harvested directly by life forms. The resultant molecular oxygen accumulated in the atmosphere and, due to interaction with ultraviolet solar radiation, formed a protective ozone layer in the upper atmosphere. The incorporation of smaller cells within larger ones resulted in the development of complex cells called eukaryotes. True multicellular organisms formed as cells within colonies became increasingly specialized. Aided by the absorption of harmful ultraviolet radiation by the ozone layer, life colonized Earth's surface. The earliest fossil evidence for life is microbial mat fossils found in 3.48 billion-year-old sandstone in Western Australia. Biogenic graphite found in 3.7 billion-year-old metasedimentary rocks in western Greenland, as well as remains of biotic material found in 4.1 billion-year-old rocks in Western Australia. Since the 1960s, it has been hypothesized that severe glacial action between 750 and 7 quintillion 16 quadrillion 183 trillion 34 billion 80 million Spadesuit 580 Maya during the Neoproterozoic covered much of Earth in ice. This hypothesis has been termed snowball Earth, and it is of particular interest because it preceded the Cambrian explosion, when multicellular life forms began to proliferate. Following the Cambrian explosion, about 7 quintillion 16 quadrillion 168 trillion 833 billion 160 million Spadesuit 535 Maya. There have been 5 major mass extinctions. The most recent such event was 7 quintillion 15 quadrillion 208 trillion 280 billion 160 million Spadesuit 66 Maya, when an asteroid impact triggered the extinction of the non-avian dinosaurs and other large reptiles, but spared some small animals such as mammals, which then resembled shrews. Over the past 7 quintillion 15 quadrillion 208 trillion 280 billion 160 million Spadesuit 66 Maya, mammalian life has diversified, and several million years ago an African ape-like animal such as Aurantugenensis gained the ability to stand upright. This facilitated tool use and encouraged communication that provided the nutrition and stimulation needed for a larger brain, which allowed the evolution of the human race. The development of agriculture, and then civilization, led to humans having an influence on Earth and the nature and quantity of other life forms as no other species ever has. Predicted future estimates on how much longer Earth will be able to continue to support life range from 500 million years to as long as 2.3 billion years. Earth's long-term future is closely tied to that of the Sun. As a result of the steady accumulation of helium at the Sun's core, the Sun's total luminosity will slowly increase. The luminosity of the Sun will grow by 10% over the next 7 quintillion 16 quadrillion 347 trillion 133 billion 600 million spade suit 1.1 ga, and by 40% over the next 7 quintillion 17 quadrillion 110 trillion 451 billion 600 million spade suit 3.5 ga. Climate models indicate that the rise in radiation reaching Earth is likely to have dire consequences, including the loss of the oceans. Earth's increasing surface temperature will accelerate the inorganic CO2 cycle, reducing its concentration to levels lethally low for plants in approximately 500,701,628,401,840,000 spade suit 900 ma. The lack of vegetation will result in the loss of oxygen in the atmosphere, so animal life will become extinct within several million more years. After another billion years, all surface water will have disappeared and the mean global temperature will reach 7 quintillion 2 quadrillion 343 trillion 150 billion spade suit 70 degrees Celsius. Earth is expected to be effectively habitable for about another 7 quintillion 16 quadrillion 157 trillion 788 billion spade suit 500 ma from that point, although this may be extended up to 7 quintillion 16 quadrillion 725 trillion 824 billion 800 million spade suit 2.3 ga if the nitrogen is removed from the atmosphere. Even if the Sun were eternal and stable, 27% of the water in the modern oceans will descend to the mantle in 1 billion years, due to reduced steam venting from mid-ocean ridges. The Sun will evolve to become a red giant in about 7 quintillion 17 quadrillion 157 trillion 788 billion spade suit 5 ga. Models predict that the Sun will expand to roughly 1 astronomical unit, which is about 250 times its present radius. Earth's fate is less clear. As a red giant, the Sun will lose roughly 30% of its mass, so, without tidal effects, Earth will move to an orbit 1.7 astronomical units from the Sun when it reaches its maximum radius. Earth was, therefore, once expected to escape envelopment by the expanded Sun's outer atmosphere, though most, if not all, remaining life would have been destroyed by the Sun's increased luminosity. A 2008 simulation indicates that Earth's orbit will decay due to tidal effects and drag, causing it to enter the red giant Sun's atmosphere and be vaporized.